It's quiz time all the time in here, but they're all short and they're all how short? Very, very short. Like you can finish in 5 minutes short. Okay. Now, not every quiz in the history of chemistry 11 is that short. Most of the quizzes in Unit 1 are teeny tiny. Finish in 5 minutes, maybe 7 tops. You know what I mean? Like short. So we have one quiz coming up tomorrow. And it is on section 1.2 only. And that is accuracy and precision. Now, if you want more details, what kind of questions are you going to get? You can head on over to Teams and say, oh, we have some upcoming quizzes and tests. Friday, January 31st. It says there will be a question with the targets. There will be a question with a data set where you need to take the average to determine the accuracy. There will be some definition-related questions. Extra practice is on page 40. There is only one retake for this quiz. Okay? So you can get a little extra information here. Let's, while we're here, start a post because on Monday, which is going to be February the 3rd, there's going to be a quiz on units and quantities. So it is just the table. Liters, meters, moles and Kelvin, kilograms and seconds, liters, meters, moles and Kelvin, kilograms and seconds. And you need to know that that goes along with volume, distance, amount of matter, temperature, mass, time. Yes, and you need to be able to fill in that chart, and you should know that, write out the whole word. Liters, meters, moles and Kelvin, kilograms and seconds. And you should know that the abbreviations for the volume distance are capital V, small d, N for the number of atoms or number of particles, temperature, because temperature is a bigger word than time, mass, and time. There we go. Okay, I should actually switch these around. Yes? So that's your quiz on Monday. It'll just be filling in the chart. You'll get a blank chart, fill it in. Is good? Okay. No, tab. Why are you not tabbing? Oh, because it doesn't like to tab, because it's Microsoft. Right. Okay, so that's our post. And then on Tuesday, that would be February the 4th, there will be a quiz on counting sig figs. So we're going to go over that again today just to remind you of the rules and do a little practice and circling the uncertain digit. There will be a quiz on counting sig figs and circling the uncertain digit. All right. So in order to prepare us for that one, I'm going to get you guys to see if you can write down for yourself on any piece of paper you want the rules regarding zeros and whether they are significant or not. See if you can do that. See if you can write it down. And if you choose not to write it down, Never come to me at the end of term and say, what can I do to make my grade better? Because I will say you can invent a time machine, go back in time and write things down when I ask you to write them down. Yes? I'm only asking you to write it down because it's good study. Yes? No, I'm making you write them down now because often people don't bother to remember them, right? They're like, oh, I don't know. I kind of know it. I've heard it. Sure. But if you can't write them down, then you don't know them. So write them down now. See if you can remember them.
Hold on. Was the right side called trailing or was it trailing?
The right side is called trailing, but you can just call them zeros on the right side. Yeah.
Rules for zeros.
Rules for zeros. Yeah. Okay, and while you guys do that, I'm going to take attendance, and I'm also going to see who doesn't have a piece of paper out and a pencil out and take note of them. And I'm looking at you. Okay, let's see who's here today. Listen's here. Listen, where are you? Oh, right there, right in front of me. Okay. Taranya's here. Beta is here. Young is here. Xavier. Greta. Is Greta here? No, Greta is not here. Okay, Gustavo's here. Rico, has Rico arrived yet? Not yet. Owen is here. Bahar is here. Taram is here. Yeonju is here. Charlotte is here. Brandon's right there. Okay. Mom is right in front of me. Tanya's away. Tanya's away. Oh, she's here, but she's not here. Okay. Okay. Lasia's here. Mohammed is here. Jofi is here. Chelsea's here. Ella's here. Matthew is here. Noah's here. Dina is right here. Samved is right over there. Okay, good. Let's see. Julia's here. And Caitlin's here. Okay, good. Okay. All right, anyone got a rule for sig figs to tell me?
I got you.
Just one. Just tell me one.
Never mind.
Just tell me one of them. Who's got one rule for me? Yes. Pardon me? Leading zeros? Okay. Are they significant or not? No. Not significant. All right, number 2. Captured zeros. Yeah. And then finally, our third rule, Hi. Thank you. Yeah, no worries. Well, what am I going to do with it, right? All right, and captured zeros, yes. Our last one. Trailing zeros. Maybe. Yep, maybe. Decimal, yes. Significant? Yes. Decimal, no. Significant? No. And what the heck are these leading and captured and trailing zeros that we're talking about? Well, if I've got 0.004008100, these zeros on the right, those are no.
Yeah, right. Oh,
Or sorry, on the left. I have a tendency to say left and right backwards. Please catch me on that. Like if I'm pointing to the left and saying right, it's just my brain doing its own little stupid thing. I'm like, turn right, turn right. You know, my person in the car with me is turning right, and I'm like, no, the other right. Anyway, my fault. Okay. Captured zeros. Yes. And finally, our trailing zeros.
no one's in the mnemonic device.
Maybe. Sorry?
No one's in the mnemonic device. NYM.
NYM. Yep. Okay. So that's our little mnemonic device there. And so if you had just 40008100, then these two would be yes, because there is a decimal. Yeah. These two would be no, because there's no decimal. And we're just going to spend another couple minutes on the over bar as well, because I know that's a little confusing, right? The over bar only goes on a zero, no other number, only over top of a zero. And only if there is no decimal in the number. You would never use an overbar when there's a decimal in the number. And the reason is that overbar says this digit is my last significant digit. If I have a decimal in the number, I know that the last digit is my last significant digit. If I have a non-zero digit, I know for certain that that digit is significant. All non-zero digits are always significant. So I would never do 4001 and stick a bar over that one, because I already know that that one is significant. I would never do that, because I already know that that last zero is significant because there is a decimal. Okay? And by the way, if I'm ever doing notes like this and you would like a printout at the end of class, you can always come up to me at the end of class and say, hey, could you print this out? Right? And it doesn't take much time for me to just make a quick printout of it for you. Okay? So let me know. All right? And if there's a bunch of people, I can make many copies. Okay? So here we have our overbars. That's when we don't use them. What does it mean when we do use them? Let's take a look at the number 6,000, okay? If I do 6,000 and I put an overbar here, that tells me that 0 is the uncertain digit. And if that digit is uncertain, what that means is that that 6,000 is actually 6,000 plus or minus 10, because my uncertainty is in the tens position. Yeah? Here's my uncertainty in the tens position, so it is plus or minus 10. What that means is that my number could be 5,990, or it could be 6,000 with this digit being uncertain, or it could be 6,010. In all of those cases, we have 1, 2, 3 sig figs. 1, 2, 3 sig figs, because remember, the uncertain digit is our last sig fig. And 1, 2, 3 sig figs. If we write the number 6,000 and we put the overbar here, what that tells us is that we have 6,000, not plus or minus 10, but now it is plus or minus how much? Oh, yeah. 100, okay? So that could be 5,900, or it could be 6,000, or it could be 6,100. And in each case, we have 2 sig figs, 2 sig figs, 2 sig figs. Yeah? Lastly, we could have 6,000 and we could put the overbar here. And that means that it is 6,000 plus or minus how much? 1. So it could be 5,999 if we go down 1. Or it could be 6,000. And we're there, or it could be 6,001. We have 4 sig figs. We have 4 sig figs. And we have 4 sig figs. Don't like the overbar? That's okay. We can write it in scientific notation, which we'll go into in more depth tomorrow. But for today, let's just look at the number 6,000. Yes, because all of these are different versions of 6,000. Don't jump all over on me, please. Stay big. There we go. Okay. 6,000 is equal to 6 times 1,000. Can we all agree on that? Is that true? True. And can we agree that 1,000 is 10 times 10 times 10? 10 times 10 times 10 is 1,000. Okay. 10 times 10 times 10. That's 1,000. And can we agree that 10 times 10 times 10 is 10 to the 3? Okay. Okay, so that is 6,000. And if I wrote this number and there was no decimal and there was no overbar, how many sig figs in this 6,000? There's no decimal. And if there's no decimal,
There's only one sig.
there's only the zeros on the right do not count, and there is only one sig fig. Okay? And you can see when we write it in scientific notation, it very clearly shows us that there is one sig fig. Okay. Now, if we go back to these other ones here, this guy here, this would be 6.00 times 10 to the 3 because we have 3 sig figs. This guy here, 2 sig figs, so we would write 6.0 times 10 to the 3, 2 sig figs. That looks like a 4, but that's just because my pen went crazy. Let's fix that. 2 sig figs. And this one here, 1, 2, 3, 4. Sig figs would be written as 6.000 times 10 to the 3. Yes? We could also write this one as 6,000 with a decimal at the end. That would also make those zeros significant. So all of those have 4 sig figs. Is good? Okay. And don't worry, if you never get the overbar, it's okay. Like, it's not like a huge important skill for the rest of your life. You know what I mean? Like, there's important skills. Being able to count the number of sig figs, excluding the overbar, is an important skill. If you don't get that one, it will screw you over all through Chem 11 and all through Chem 12 because you'll lose a half mark every time you get it wrong. Yeah? And we do calculations all the time, and you need to be able to count those sig figs, so you need to make sure you know that. And that's why if you do poorly on your quiz on Tuesday, you'll know where you went wrong, and you'll be able to study and do better. Hello! You are new?
Yeah.
Okay, cool. Let us find you a book. Here, come here. And let's get you as 6 Yeah. As long as it's not like, as long as you're not getting in people's way or, you know, making noise or whatever, it's all good. It's all good. We have chairs kicking around places. Just look at the back or the side. There's chairs all over the place. Okay. So what we're going to do now is we are going to go and we are going to apply our knowledge. We are going to be on page 97. Page 97, 1.5a. Page 97 gives you the rules. So if you have your book and you have it open, you'll have the rules there. And then on the next page, you can see we have some exercises. Okay? I would suggest that you're probably okay with 1 and 2. Don't spend much time doing 1 and 2. I would move on to number 3. Okay? And in number 3, what you will do is you will determine the number of sig figs in each of the following numbers. And then I don't have this on my copy. I don't know why. However, I think question 4 says circle or highlight or underline the uncertain digit. Pick one, circle, highlight, or underline. So you're going to be doing 3 and 4. And I'm going to be coming around, taking a little check-in with you and seeing how you do with that, okay? The other thing you should be doing is when you finish, if I haven't checked your work yet, you should check the answer key. And if you're not getting something right, you're going to want to ask about it. This is your opportunity to ask questions. People who do well generally get their confusions cleared up, you know, while they're in class, or they'll pop in, you know, during after school or during flex. I've already seen people who've had their misconceptions cleared up. It's been good. No? You're going to borrow them. Look at this. Look right here. You can write in it. Yeah. You're just chilling? Okay. And you're not bothered? Okay. Okay. All right. Okay. Okay.
Oh, yeah, sorry.
But it's because everyone's so new. We'll see. We'll see. Okay, so these look very good. Okay, once you're done, circle those uncertain digits. So you're now circled your uncertain digits.
So it says underline the uncertain digit. We have something like this. When we go to something, they all come on.
Yeah.
Oh,
it's always 4 numbers. It's always 1, 2, 3, and then the 4. There's only 1, so it's always the last sig fig.
No, because in English, I don't know, is, I mean, are you
Really? What are you? I saw him. It was mad. I really
Strong, like I'm strong. I did.
Okay, yeah. So you can always just think back and go, oh, the one where I are.
You wish.
I've never seen So now. Maybe.
Yeah.
Only if there is investment.
Yeah.
I would then answer yes.
So you can help.
Yes.
How do you get, are we in trouble?
I see it trophy.
It's how much she was feeling.
So I see.
Oh, yeah, I did.
I was getting.
Okay, so
Yo, where's the thing she gave me? Grab this. Well, she told me to take the thing. What is it called?
So you have,
So this is what we.
you don't have any.
I didn't understand what to go through. I read the chemistry.
Like I
guess so.
Yeah.
I was
It is not certain, it is just water. So it's all the certificates, there might be none of them, there might be no certificates, all of them there.
No, that's not. Yeah.
Okay, so this was. That one, zeros on the right.
I would have.
That
I'm not.
was in history. Mr. H was not. Gandhi, you say half an hour.
Mr. H is too nice to be someone of the same school.
Well, your tastes were so easy, but is there
You should join them for a walk. This is one. I mean, I'm not that dumb, but you're in the start of the podcast. I'm gonna reject I would write No, we went to the Starbucks class.
Do you understand this? No, okay. So here's what it is. You do understand, okay, you understand.
Alright, I'm supposed to.
Are you I can tell. Are you just just fine. Or like, you gotta go, so you gotta have this or that. Or that. Yeah. Yeah, well, we're not just not. This one's gonna. Right? Yes.
What?
I was kidding. He like took his time with it. I was
So we.
And then was like this.
So he does it every day. He does it
Is there a decimal?
Right now.
No decimal? We have one sick day. So you don't have to have certain things. So we're like, you have one sick day, one sick day. So it's all certain, all the certain ones, but it has, you do not look at all
All your
yes.
tools are correct.
Right? Is this?
You know, you know, like, look at.
Oh. So, how does this one work? Okay, so are you? Maybe. That's gonna take decimal. Yes. Yes. Well, I don't see any numbers. If you had five. Sort of, yes, not really, okay.
If there's a decimal, if there is a decimal, even the numbers, any numbers to the right are.
Yeah.
It's
like more right.
So it doesn't matter.
Right.
Brad, listen, the quiz is not on this.
Yes.
So,
You only need to switch it. That's the thing. Because it doesn't. See that in the number after this one. Question?
Yeah.
No.
For each one, yeah, there's a one. Yeah.
So we just have to go through and see my
What are you so awesome?
Like really a what?
Oh yeah. That's the hardest. This time we'll This one. Oh, yeah. We saw the video. So I'm talking about some kids require. And this some I've never seen before. One guy goes, oh, that. So yeah. I'm like, no. And he opens up his phone and says,
Why?
because he opened up his phone, right? So I was like, sign. So you're up and you sign like, okay, let's go. Okay. He opens it. And he's like, yeah, no, right? But she's the number is after. Yeah, it was after. Yeah, but after all these numbers. What's the one side? Yeah, so he's from years. Okay.
Wait, no, you're not like, you're fine, you're great.
He shows the second video. And you see it slowly creep like that.
Like, here's on
That's something that's increased on Monday. So it's 20 minutes. Figure out 20 minutes standing outside the door. Standing. And you're all eventually.
Okay, that's, no, we have 20 minutes left. Oh, I thought you said 10. Okay. All good. Then yes, we have 10, we have 20 minutes left. All right, so our next thing is we are going to go to, where is it? Is it this one? Yes. Page 47. Page 47.
Yeah, actually, yeah. It just, it brings bad future.
Bad vibes. Bad vibes. Okay. So last day, Monday, on Monday, we had looked at elements. Yes, on page 46. And elements are when all the atoms are the same. So an element, all the atoms are the same. Okay? And on the next page, which we did not get around to, we have molecules of elements. This is page 47. Okay, so make sure you're on 47. Sometimes atoms join together. What do we call it when they join together in chemistry? When atoms join together, we say that they bond. Yes. And when they bond together, they can make molecules. Now, actually, I would like to be more specific here. When we say some elements that form molecules, not just any elements, they're always going to be non-metals. If you've got a molecule, it's made of nonmetals. One of the elements that exists like this is hydrogen. Each hydrogen atom joins up with another hydrogen atom to form a hydrogen molecule. Now, why the heck does it bother to do this? Why does it not just float around as an H? Well, let's try and remember how to draw a Bohr model for a hydrogen atom. Hydrogen is atomic number 1. What does that tell us? Atomic number 1 tells us hydrogen has 1 proton. So we're going to draw 1 proton. How many electrons does a hydrogen atom have? 1, because atoms are always neutral. If you have one positive thing, you must have one negative thing to make it neutral. Okay, so here is our negative electron. So that's 1 hydrogen atom. Here's our other hydrogen atom with its proton and its electron. How many electrons makes a full shell number 1? 2. So is hydrogen full or not full? Not full. Do atoms like to be full or not full? They like to be full. That is a stable state for them. Okay, when I say stable, what I'm referring to is if I have this calculator up here, it is unstable compared to being down there. Things will naturally go to a more stable state. And in order to get them to go to a more unstable state, I would actually have to do work. Yes, I have to lift it up, but naturally it will fall down. So these hydrogen atoms will naturally go to their most stable state, which is where they have 2 electrons. How could these 2 hydrogen atoms help each other out? They could join together. They could be like, I will share with you if you share with me. Okay? So we would now have our 2 electrons being shared.
You can go right now, yeah. The lesson's being recorded, so anything you missed will be on. Okay.
Okay, so we have hydrogen A, we have hydrogen B, and they are now sharing their electrons. What kind of a bond do we have if we are sharing electrons? Do you guys remember that? Covalent bond. So if we're sharing electrons, that is a covalent bond. And I'm just going to mention this now.
How are you? Did any of you go see Ms. Sabrina? Oh my God. How are you?
Sorry, guys.
Sorry. Former student, so good to see you. How are you? Good.
Yeah, she just drew that. The drawing like you that's pretty good.
Yeah.
It's near downtown.
Okay, so with that,
Former students, I will let you know that she was not my brightest student. I'm not saying she was dumb or anything. Like, she just wasn't like A plus based on, what naturally was up here. But she got like always over 90% in everything. She just worked her ass off. She was such a hard worker, and she has been so successful in everything she's done just because she's got that attitude of, I can do it and I can work for it and I can get it done. And she's actually gone on to be like a Miss World, like, contestant and things like that. Anyway, and she just did that like on a whim. She did it like as just kind of a like whatever. Anyway, yes. What does she do right now? I can't remember. I mean, right now she's busy being Miss World, whatever, and going around and doing talks and things like that because that's part of what it is. But, she's... I have a feeling she could do anything she wanted because she's just like, a go-getter. Goes and gets. Go and get things. Yes? My son is not a go-getter. My son's a sit-at-home. Hopefully things will happen. I'm not saying he doesn't do a lot, but he's not, he doesn't have that hustle to him. You know what I mean? Nor do I. I'm not a hustle. So no. So I work hard, but I don't always have 1,000 ideas going on, and I'm not out there. I don't have a side hustle. No, I'm I have a job. That's my job. I'm just doing that. Anyway, so we only have 10 minutes left. So let's stop talking about all this and let's talk about these covalent bonds. And so covalent bonds, I just wanted to mention that these are very strong, because that's going to become important in a while. Okay, so they're very strong. Ionic bonds, also very strong. Basically, any type of bond, strong. All right, we'll contrast that with intermolecular forces later. Those are weak. At any rate, this is our hydrogen molecule, and the formula And the reason I'm highlighting this one is that in math, formula and equation are used almost interchangeably, yes? Like you solve an equation, you solve a formula, blah, 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 that's math. Chemistry, formula for hydrogen is H2. In chemistry, if you write an equation, your equation would be like H2 plus O2 gives H2O. That's an equation. Oh, did I do that wrong? Yeah, there we go. That's an equation. The formula is just for a single chemical, like H2 is a formula. O2 is a formula. H2O is a formula. The equation is like the whole thing. All right. The hydrogen atom is made of, hydrogen molecule is made of how many atoms? 2 atoms. And so we call it a diatomic molecule. And the reason we call it diatomic is because di means 2. Other elements such as nitrogen and oxygen and chlorine also exist as diatomic molecules because they all contain 2 atoms. I would like you guys to write the formulas for these elements, nitrogen and chlorine and oxygen. So the symbol for nitrogen is N, but nitrogen is diatomic. So what would we have to add to the end of that? We would have to add a 2. So we have N2, O2, Cl2. Do you remember what we call these little numbers at the bottom? Those are called subscripts. The prefix sub means below. So if you go in a submarine, it goes under the water, below the surface of the water. Okay? What do you think script means? Writing. So subscripts go below the writing. So this is a molecule. Atoms can also join together, not to make a molecule of an element, but they can also join together to make a compound. What's different about this? Is that a compound? It's not a compound because it has only the same atoms. However, we can make a compound. Let's say we took 2 or more different elements and we put them in a chemical reaction, and they don't just mix, we actually have a chemical reaction, and so they become joined. What's the chemical word for joined? Bonded. Okay, so they become bonded to make to one another in order to make a molecule. Whoops, Le. In this case, a compound when they're different. So they have to be different in order to get a compound. We'll talk about ionic in a minute. Yeah? because these are non-metals only. So I have a non-metal element. And I have another non-metal element. And you'll notice that here, all the atoms are the same. And that is why, if all the atoms are the same, that's why it is an element. So hydrogen is an element. All the atoms are white colored balls with H on them. Not in reality, but you know, you get the idea? Okay. Oxygen is an element. How do we know it's an element? Because all the atoms are the same. However, when we look at water, the atoms are different. And that is what makes it a compound. Is good? So if the atoms are the same, it's an element. If the atoms are different and they're bonded together, that is a compound. Here's a question for you. Are all molecules compounds? And I'm putting a star beside it because it is a favorite test question of mine. Love to ask it on a test.
Are you going to ask why in that test or no? Are you going to ask why in the test or no?
I might ask you to explain.
Oh,
Yeah? Are all molecules compounds?
no.
No. Why not? Some molecules, and I'm going to show you my abbreviation for molecule. It's capital M, capital C, okay, because we write molecule a lot in this course. It's nice to shorten it. Some molecules are not compounds, but rather they are that's a hydrogen molecule. Is that a compound? No, it is an element. So not all molecules are compounds. Some molecules are elements. So for example, H2. Okay, now we did not get as far as my other class did, so what I'm going to do is their homework was to do pages 50, 51, 50, 51, 52. Pages 50 to 52, but you guys are going to get a bonus on Teams. I'm going to post in their video where you should watch from to get the last part of the lesson. You can also just read the thing and see if you can figure it out, okay? Plus, watch video lesson in Teams. It's probably about 10 minutes, maybe 5-10 minutes. I'll post it in the homework. Posted in homework. Also study for your quiz for tomorrow.
Oh,